Hi students, today we are going to learn about functions. The objectives of this chapter are: determine the sign of a polynomial, determine the domain of definition of a function, study the parity of a function and the elements of symmetry, determine the limits of a function, determine the derivatives of the function, apply derivatives. We start with part 1, determine the sign of a polynomial. First degree polynomial. The form of first degree polynomial is ax plus b, and a should be not equal to 0. To determine the sign of a polynomial, we determine first the root of p of x. The value of x when p of x equal to 0 is minus b over a. To find the sign of p of x, we draw the table of sign of p of x. We first put the domain of the polynomial. Since p is a polynomial, the domain of definition of p is from minus infinity to plus infinity, and then we put the root of p of x, which is minus b over a. The sign of p of x is before the root minus b over a is opposite sign of a, and after minus b over a is the same sign of a. Example 1, study the sign of f in each of the following cases. Part 1, f of x equal 2x minus 3. First, we calculate the root of f of x. We solve f of x equal to 0, then x equals 3 over 2. Then draw the table of sign of f. Since f is a polynomial, since its domain is from minus infinity to plus infinity, and we put the root, which is 3 over 2. A is 2, which is positive. Since a is positive, then we put before 3 over 2 opposite sign of a, which is negative, and after 3 over 2 same sign of a, which is positive. 2. F of x equal minus 3x plus 6. First, we find the root of f of x equal to 0, then x equal 2. Then we draw the table of sign of f. Since a is minus 3, which is negative, then before the root 2 opposite sign of a, then it's positive, and after the root 2 same sign of a, which is negative. Second degree polynomial. Second degree polynomial. The form of second degree polynomials is p of x equal ax plus p of x plus c, and a should be not equal to 0. To find the sign of, or to determine the sign of polynomial p of x, first we start to calculate the roots of p of x. We have three cases. If delta is positive, then there are two distinct roots, x prime and x double prime. In this case, the table of sign of p of x, as you see, its domain from minus infinity to plus infinity. Since it's a polynomial, its domain all real from minus infinity to plus infinity, and we put the roots of p of x, which is x prime and x double prime, interior between the two roots x prime and x double prime. The sign of p of x is the opposite sign of a. The a is the coefficient of x power 2, and before x prime and after x double prime the sign of p of x is same sign as a. If delta is negative, then p of x has no real root. In this case, the sign of p of x from minus infinity to plus infinity is the same sign as a. If a is positive, then p of x is always positive, and if a is negative, then p of x is always negative. If delta equal to 0, then there is a real double root x prime equal x double prime equal minus p over 2a. Then we draw the table of sign of p. Its domain is minus infinity plus infinity. The root is minus p over 2a. Before and after the root, the sign of p of x is the same sign as a. Exercise 2. Study the sign of f in each of the following cases. Part 1. F of x equal x power 2 minus 3x plus 2. We find its root. We have delta greater than 0, or by calculator we find the two roots x prime and x double prime, x prime equal to 1 and x double prime equal to 2. Then we draw its table of sign. We put first the domain of definition of f. Since f is a polynomial, its domain is minus infinity plus infinity. The roots are 1 and 2. Since we have two distinct roots, then the sign of f of x is between 1 and 2, opposite sign of a. A is 1, it's positive, then the sign between 1 and 2 is minus, and before 1, after 2, same sign of a, which is positive. 2. F of x equal x power 2 plus x plus 2. We have delta negative. Then the sign of f of x from minus infinity to plus infinity, same sign of a. A is positive, a is 1, then it's positive. Then f of x is positive for all real values of part 3. F of x equal x power 2 minus 4x plus 4. We have delta equal to 0. Then we have double root x equal minus 3 over 2a equal 2. Then we draw the table of sign of f. Its domain is minus infinity plus infinity. The root is 2. Since we have one double root, then before 2 and after 2, f has the same sign of a. A is 1, it's positive, then it's plus plus. Part 2. Determine the domain of definition of a function. The domain of definition is the set of values of the variable x such that the image of x exists, or the domain of definition is the set of values where f is defined. Exercise 3. Determine the domain of definition of the following functions. Part 1. F of x equal x power 2 plus 3x minus 4. Since f is a polynomial, then its domain is R from minus infinity to plus infinity. 2. F of x equal x minus 1 over x plus 5. The condition on f is the denominator should be not equal to 0. Then it's necessary that x plus 5 not equal to 0, then x not equal to minus 5. So the domain of f is from minus infinity to minus 5 excluded union minus 5 to plus infinity. Part 3 equal radical 2x plus 3. It's necessary that 2x plus 3 greater or equal to 0, then 2x greater or equal to minus 3, and so x greater or equal to minus 3 over 2, then its domain of definition is minus 3 over 2 close to plus infinity. Study the parity of a function f. 1. We start with even function. Definition. F is said to be an even function if and only if its domain is centered at 0 and f of minus x equal f of x. We call domain is centered at 0 when x and minus x belong to the domain of f. And if f is an even function, then the axis y prime oy is the axis of symmetry of the curve represented f. Example, shows that the function f of x equals dx squared minus 4 is even. To show that f is even, we first find its domain of definition to show if it's centered at 0. Since f is a polynomial, then its domain is R from minus infinity to plus infinity, and R is centered at 0. Then we calculate f of minus x. F of minus x equals 3. We substitute x by minus x, then we get that f of minus x equal f of x. Then f verifies the two conditions, then f is an even function, and y prime oy is the axis of symmetry of the curve represented f. Odd functions. Definition: f is said to be an odd function if and only if the domain df is centered at 0 and f of minus x equal minus f of x, and if f is an odd, then the origin or the origin of the system O is the center of symmetry of the curve that represented the function f. If f of x shows that the function f of x equal 2x power 3 minus 5x is odd. First, we find its domain of definition. Since f is a polynomial, then the domain of definition is R, which is centered at 0. And then we calculate f of minus x equal 2 into minus x power 3 minus 5 into minus x, so it's equal to minus into 2x power 3 minus 5x, and hence it's equal to minus f of x, so f is an odd function. Axis of symmetry of the curve. D is a straight line of equation x equal a, is said to be an axis of symmetry of the curve of a function f if and only if the domain of f is centered at a and f of 2a minus x equal f of x. For example, consider the function f defined by f of x equal x squared minus 2x plus 5. Shows that the line D of equation x equal 1 is an axis of symmetry of the curve CF. First, we find the domain of f. Since f is a polynomial, then its domain is R, which is centered at a equal to 1. Second step, we find f of 2a minus x equal f of 2 minus x. Substitute x by 2 minus x. Then we see that f of 2 minus x equal f of x, and hence x equal 1 is the axis of symmetry of the curve. Center of symmetry. The point I of coordinates AB is the center of symmetry of the curve of a function f if and only if the domain of definition of f is centered at A, and verify the condition that f of 2a minus x plus f of x equal to b. For example, let f of x equal x plus 1 plus 2 over x minus 3. Shows that the point I of coordinates 3, 4 is the center of symmetry of the curve CF. The solution: we begin first by finding the domain of definition of f. The domain of f x minus 3 should be not equal to 0, then x not equal to 3, and hence the domain of definition is minus infinity 3 union 3 plus infinity, which is centered at 3. Then we find f of 2a minus x plus f of x. We calculate f of 6 minus x plus f of x, and we get that it's equal to 8, which is equal to 2 times 4 is which is 2b. Then I 3, 4 is the center of symmetry of the curve CF.